Today we're diving deep, literally, into the water system for the high-definition render pipeline. The water system allows you to add high-quality oceans, rivers, pools, and lakes to your HDRP environments. Creating realistic bodies of water in your Unity scenes is just a few clicks away. In this video, we'll cover the basics of setting up a water surface from scratch. Then we'll adjust its simulation and appearance to help integrate it with the environment. Finally, we'll explore a few more techniques when implementing digital water in your Unity scenes. We cover this and more in our guide on building HDRP worlds. Follow the link in the description to download the free ebook. Though some features of the HDRP water system are available in Unity 2022 LTS, we recommend that you start with the 2023.2 tech stream or Unity 6 when it's available. To use the HDRP water system, enable water rendering in your project settings. HDRP lets you optimize which specific features are active for different quality levels. For demo purposes, we'll enable all of the available options. If you're starting with a new scene, add the water rendering override into the HDRP volume. Now we're ready to create a water surface from the Game Object menu. Three types of water surfaces are supported: ocean, sea, or lake, pool, and river. The three types differ by their wave complexity and intended use case. Choose ocean, sea, or lake, and then suddenly we have water. The water surface component contains parameters to adjust the simulation and rendering. It's part of a game object, so you can adjust the Y value of its transform to change the height of the water level. Waves are created using a simulation that combines simple waves of varying frequencies into complex patterns. The system works on ranges or sets of frequencies, which we call bands. By controlling these bands, the simulation can control the motion of the water. For the ocean, we have two bands of lower frequencies called the swell and a set of higher frequencies called ripples. If you disable the ripples and drag the amplitude of these first two bands to 0, you can see that our water surface is just a tessellated plane. This uses the GPU to generate more geometry closer to the camera, capturing extra detail where it's needed. Add back the first band of the swell, and the polygons of the plane begin to animate. Then re-add the secondary band for more detail. Finally, re-enable the ripples to apply another layer of higher frequencies on top of the swell. The simulation parameters change the water's motion. Make the repetition size just large enough so that the water simulation doesn't display any obvious repeating patterns. The distant wind speed dictates the size and movement of the larger waves, while increasing the chaos value can introduce randomness into the wave patterns. Orientation and current speed determine the overall direction and rate of water flow. You can also create other water surface types. Rivers use a band of lower frequencies called the agitation. This is equivalent to the second band of an ocean's swell. The river also adds the higher frequencies of ripples on top. Pools are smaller bodies of water that only use the higher frequency ripples. Both rivers and pools don't have the option of appearing infinite like an ocean, sea, or lake surface. Instead, you can choose a geometry type like a quad. You also have the flexibility to use a custom mesh for either of these surfaces, pass in a mesh renderer into the custom geometry type. The water surface assumes a specific shape like this. And here it is next to the surrounding environment. Or get creative and try something out of the box for some strange and wonderful effects. To better understand how to integrate water surfaces into your game environments, check out the sample scenes in the Package Manager. Here you'll find 4 demos that show how to deploy the water system in various real-world scenarios. We'll show off more features of the water system using these sample scenes. While the simulation parameters determine the water's movement, the appearance parameters determine how the water surface reacts to light. The smoothness controls the glossiness of the water surface to make it shinier or more dull. Refraction controls how the light bends when it enters and exits the water. This can help sell the illusion of depth and volume. Scattering determines the dispersion of light within the medium. Adjust the settings here to make the water more clear and pristine or more turbid and murky. For underwater views, check the underwater option on the water surface. This enables absorption, scattering, and other effects to simulate that underwater look. And while we're diving below the surface, caustics simulates how sunlight passes through water and refracts onto underwater surfaces. Adjust the resolution, simulation band, and other settings to affect the patterns of light. Then you can make caustics appear at the bottom of the pool or the seafloor. If you're not just making a flat, calm ocean or pool, then you may need to deform the water. This can help the water surface integrate into its surroundings or interact with external forces. Enable the water deformation feature in the water surface, then use a game object with a water deformer component. Position it in your scene to affect the water within the area of influence. Choose from several shapes of deformers. Shore wave deformers create choppy shorebound waves in a defined area. Sphere deformers affect the water in a spherical volume, useful for a point source bubble or an object impact. A bow wave deformation simulates the wave pattern in front of a moving boat. And a box deformation alters the water level within a rectangular zone. If these predefined shapes don't quite meet your needs, a texture deformer can define height values of the water using a grayscale image. In this example, this grayscale image drives a waterfall that connects the two water levels. Stack the deformers together for additive effects. Adjust the scale, amplitude, and other settings to control their combined size and height. While looking at this water surface by itself might not make sense, enabling the surrounding geometry can put everything in context. Current maps are textures that simulate the directional flow within bodies of water. Use them for designing how rivers or ocean currents move through the scene. The texture's red and green channels specify the X and Y directional components, and the blue channel contains the influence of the current map. You can define a current map like this externally in image editing software. To better determine the direction of the current, select the Current Debug mode. This vector field indicates the direction of the swell, agitation, or ripples. Custom scripts can make your game objects interact with the water surface. This example demonstrates how a script can make these objects appear to float. In the glacier scene, these ice flows not only float, they move with the vectors defined in the current map. The script logic plops the ice chunk straight down onto the water level and then queries the water surface component to get the proper directions. And that creates custom behavior for the little ice flows. You can make this even more efficient for multiple floating objects using the burst compiler. This example script lets you comfortably float several hundred seagulls with minimal performance hit. Foam is used to simulate the white frothy areas that typically appear in fast-moving or turbulent water. The foam settings on the water surface control its general overall appearance. Use the persistence multiplier to adjust the foam lifespan. Control the level of shininess through the smoothness parameter. Enable the simulation foam to display the foam on the crests of waves. And you can also use local foam generators throughout the scene. These generate foam dynamically at specific locations, such as around obstacles or objects in the water. In the sample, a foam trail object contains a water foam generator. This component includes customizable fields for adjusting the foam intensity, size, and texture. Water excluders are geometric shapes, such as a box, sphere, or custom mesh that can carve out areas within the water. Essentially, they create holes in the water surface, allowing for objects like boats to intersect the water without actually being submerged. Masks influence the water simulation in specific areas. Add them to exclude waves and foam, useful for integrating water with your land masses. Use the water mask's color channels to attenuate different simulation bands. This table describes how the red, green, and blue channels affect the various water surface types. Use the debug mode to visualize their effect. Choose the water mask or simulation foam mask to view the grayscale values, or debug the foam itself and see how the mask has cut away at the effect. Decals can be applied to water surfaces in the form of a layer mask. Use a decal projector to overlay effects like floating debris, additional foam effects, or visible ripples. Another application of a decal is to use a custom script to project caustics that appear above the water surface. In the glacier sample, this passes the caustics buffer from a water surface to a material. A decal projector then projects the caustic pattern onto the glacier wall. To customize the water line, the boundary where water and air intersect in a partially submerged camera, we can use post-processing. This full-screen custom pass shader graph allows for fine-tuning of the waterline's blurriness and height and adds a meniscus for a touch of realism. And that's a quick tour of HDRP's new water system. Experiment with its various features to add water surfaces to your own game environments. For more advanced use cases, this GitHub repository offers additional sample scenes. Want to know more about HDRP Water? Follow the link in the description to download our free ebook guide about building HDRP environments. Use these tips and tricks to bring your game worlds to life with realistic real-time water. Thanks for watching.